My name is Lucas and I have to discuss about electric field in previous chapter, and now I have to discuss about electric field due to a charge distribution. Okay, so now the first question is electric field on a line charge distribution. Okay, here is electric field due to a line charge distribution. In this question, the question is given is there is a rod which length is L and a point P is the distance A from the rod, and we have to find the electric field at point P due to this rod, and positive charge is distributed on this rod. Here we take a, in the previous chapter we have discussed about if there are a positive charge, then the direction, and this is trace charge. Okay, so here the direction of electric field is away from the positive charge, and here is negative charge. Here the direction of the electric field is towards the negative charge. So by this we see here कि this is a point charge, this is positive point charge. Point charge is always positive and its electric field is 2 minimum. So here electric field direction will be in the direction of P. So here is the E, and we have to find out the electric field at point P. We cannot find the electric field from this point or at the center. If we have to find out the value of electric field, so we have to integrate this from this point to this point. This is A and this is A plus L. Okay, so we take a element on this rod is dx. This element we can take anywhere on the rod, here, anywhere, and we take distance is x from the point P. Here x is variable because we can put this dx is anywhere on the rod. So electric field is any point on the will be kq upon r square. So here electric field at any point is kq upon r square, and electric field due to this small element will be dE is equal to k dq upon, here is r, then what is this? This will be x square. Here x is variable. Okay, so this is linear, and so we can write this dE is equal to, okay, here both are variable, then we have to change one in constant, so here dq and x, so we can change dq, we can write this, the linear charge density will be of this rod will be linear charge density. linear charge density होता है lambda is equal to charge upon length. So here this is element and the here charge will be dq, and the length of this dx. So here dx is equal to lambda into dx. Here is dq and dq. Okay, we put the value of dq lambda into dx here. Okay, here k into lambda into dx upon x square. Now we integrate this, okay, from where to where? A to a plus a. So here dE is equal to integration of k into lambda into dx upon x square from a to a plus l. We can write this E is equal to k into lambda is constant, so we can write this, and this will be a plus l dx x square. Okay, the integration of 1 by x square will be minus 1 upon x, so we can write this E is equal to k into lambda into dx upon x square. The integration of this will be minus 1 upon x. This is a plus l. Now we put this limit in this, so it will be k into lambda into, okay, here it will be minus 1 upon a plus l, and here is plus, okay, here, or if we can add the minus into 1 upon a. E is equal to k into lambda, this will be plus, so we can write this 1 upon a minus 1 upon a plus l. This is the electric field due to a line charge distribution. Okay, so here is these are the point is on the x component. Now we discuss electric field distribution due to a semicircle, where we saw there are two components in x-axis and a y-axis. Okay, so now we discuss about this. Now we have to discuss about electric field due to a semicircle. Okay, here is electric field due to a semicircle. Okay, here is semicircle and here is the center. This is the radius r. Okay, now I can rub this. Okay. The positive charge is distributed on this. We have to find out the electric field at the center of this semicircle. Okay. Let me take a theta angle. We cut a d theta, a small element dl, where is charges dq. Okay, so here this test charge, we take a test charge this point to this point, the electric field will be in this direction. Here is positive, then away from this point. So here is the small electric field due to the small element. Okay, here is the T. Okay, now this angle will be theta, so the component of this will be dE cos theta, and this will be dE sin theta. Where is the, if you go from this point to this point, then we found this is symmetrical. How? Okay, we go from 0 to, first we found out the value of electric field of this element, then we add of all electric field for all. Here we start from 0 degree and we increasing, then we go to pi 180 degrees. So where it first find out the electric field, what will be the What will be the electric field at any point? The electric field is at any point is E is equal to KQ upon R square. Okay. We draw a line and here you see if we make a DL element here at DQ angle, so the electric field of this D, and this will be angle theta because of we take this theta, so here this is D cos theta and this will be component D is sin theta. Leaves are left and right bisymmetric, this will be plus and this is minus, then both will be cancelled out. So we discussed about the y component, not discussed about x component because x component will be cancelled out. So here is the electric field at any point K E is equal to KQ upon R square. Okay. Electric field is a y component will be dE of dE sin theta. And now we integrate to from 0 to 180. So we can write this dE is equal to D, we can write this K into dQ upon R square into sin theta. Here R is not variable because of this is the radius of this circle and the circle of this radius is not variable. Okay. The linear charge density of this semicircle will be here. The linear charge density, lambda is equal to charge upon length. So charge, what is charge? Is dq and length is dl. So we can write this dq is equal to lambda into dl. So here we fit k into dq, we can write this lambda into dl sin theta upon r square. Okay. Here we saw that theta is variable. Okay, so we change this dl into theta. How? Okay. Now we zoom it. Okay. By zoom this figure will look like this. Okay, and this is d theta and this is dl and this is r. So we can write this. We know that dl, we can write this dl r is equal to radius into angle. So r into d theta. Where we put this dl is equal to, we can put r into d theta. Okay. Then d theta is equal to k into lambda into r into d theta into sin theta upon r square. Okay, this will be dE is equal to k, r and r will be cancelled into lambda upon r, and this will be sin theta into d theta. Now we integrate this from where to where? From 0 to pi. 0 to pi. Okay, then we find E is equal to k lambda upon r is constant, so now we out this and integration of sin theta will be minus cos theta from 0 to pi. E is equal to k lambda upon r. Here we can write this. Now we put the limit of this, so this will be minus cos pi and minus of cos 0 degree. Okay, this is k lambda upon r. This will be 1 and this will be also plus 1. Okay, So we can write this 2k lambda upon r. E is equal to, so this is the electric field in the center of this semicircle is E is equal to 2k lambda upon r. You can ask me what is the electric field due to the whole circle. Okay, the whole circle of this electric field will be 0 because of, we saw here this is a semicircle and the semicircle of this x component will be cancelled. If this is a whole circle, their y component will be cancelled out. So here